Welcome back. Today we are going to look at section 2.7. We are dealing with absolute value functions and graphs. And our target today is to be able to graph absolute value functions. So an absolute value function would look like this. F of x equals the absolute value of x. It will be a V-shaped graph. It is symmetric about a vertical line that we call the axis of symmetry. It has a single maximum point or a single minimum point called the vertex. And the slope of the right branch is 1 and the slope of the left branch is -1. So let's look at why all of these things are true. If we made a table of values where we started with -3 and went up to +3 and we're plugging those numbers into this equation, y equals the absolute value of x. The absolute value symbol there just tells us that it's going to turn whatever we plug into inside that absolute value bars, it will turn it positive. So if we plug a -3 in, we're going to get a +3 out. If we put a -2 in, we're going to get a +2 out. Okay? So if we were to plot those points, -3, 3, -2, 2, -1, 1, 0, 0, +1, 1, +2, 2, 3, 3. And we get this V-shaped graph. Now, it said that it is symmetric. Our line of symmetry in this case is going to be the y-axis. All right? In other words, if we folded our graph, if we folded the paper along that dotted line, the two sides of our V-shaped absolute value graph would line up. So our axis of symmetry in this case would be the equation x equals 0, that vertical line. The vertex of our graph is down here. For this particular question, it is at the origin. And it says the slope of the right branch is 1. So if we look at the slope here, we're going up 1 over 1, up 1 over 1. So our slope is +1. But on the left side, we have to go up and back, or down and to the right, either way. So our slope here is -1. The notation that you see here is the algebraic way of saying this. For an absolute value graph, the absolute value of x is x if x starts out positive or 0. In other words, the absolute value of 0 and the absolute value of any kind of positive number is going to come out just whatever was inside. The second statement here says the absolute value of x comes out as the opposite of x. So if we plug a negative number in here, it's going to come out as the positive version. So it's going to be the opposite of whatever we dumped in, since that was already a negative number. All right, so how do we go about graphing these? Well, these transform just like all of the other functions that we've been talking about. So when we look at our a, h, and k values, our a, remember, is that vertical stretch or compression. Our h value moves things to the left and right, and our k value moves things up and down. So the same way that we've been graphing all of our functions, we can look at absolute value and transform those. What's nice about absolute value is this a piece is going to be your slope of the right branch. So if our v gets stretched, instead of being like this, if we stretch it and it gets skinnier, well, now this a value is going to be the slope of that new right side. So to graph them, our first step is going to be to identify the vertex based on any kind of shifting left and right, up and down. And then we're going to use our slope to make our v. All right, so for this first one, notice that our a value is 1, so we haven't stretched or compressed it at all, which means our slope on the right-hand side is going to be 1. Okay. The other kind of transformation that we've done to this is we've shifted it to the right 2 and up 3. So picture taking our normal absolute value graph that had a vertex at the origin. So our normal graph was 0, 0, 1, 1, 2, 2, 3, 3, etc. And same on the left side going. I'm going to pause the video for 1 second and reorient my board. All right, let's try that again. Our normal absolute value, just y equals the absolute value of x, has a vertex at 0, 0, and a slope of +1 on the right side, and a slope of -1 on the left side. Okay, we haven't changed the steepness of our graph for this new equation because our a value is still 1. But what we've done is we've shifted it to the right 2 and up 3. So picture taking all of those points that I just plotted. I'm going to start with our vertex. If I shift it right 2 and up 3, it lands there. That's going to be my new vertex. And I can shift all of these points right 2 and up 3. But what's going to happen is I'm going to get that same sloping line that I had originally. So the key to finding the location of an absolute value graph is to start out by looking at where that vertex shifts to, and then we can just graph the 2 branches of it using our slope. Our axis of symmetry for this one has shifted and is now the line x equals 2. All right, it should go with whatever left or right shift that you've had. Our domain is all real numbers because we can plug any value for x into our absolute value equation. So x is going to be all reals. But our range, you'll notice there is a cutoff, right? We don't have any y's below that value. So our range would be y has to be greater than or equal to 3. And that's going to pair up with any kind of up and down shift that we've done. All right, let's try another one. Y equals the absolute value of x plus 4 minus 1. Again, our a value is 1. All right, we haven't stretched or compressed it at all. We have shifted it from here left 4, and this tells me I went down 1. So our vertex is going to move from the origin, from here, it's going to go left 4 and down 1. This is my new vertex. My coordinates would be -4, -1. My axis of symmetry always has to go right through that vertex. So I know that my line of symmetry is going to be here, has an x coordinate of -4. My domain is always going to be all reals. We can plug any values into our absolute value equation. But my range, if I think about what this graph's going to look like, we said we had a slope of 1. So the slope on the right side is going to be 1. The slope on the left is going to be -1. All right, so on the right side, I'm going to go up 1, right 1, and draw my line, my right side of my branch in. And then for the other one, I'm going to go up 1 and left 1 to get the left side of that. So my range, you'll notice that the lowest I get is a -1. Okay, whoops, -1, that's my cutoff. So my range is going to be y has to be greater than or equal to -1. All right, let's try our next example. Notice that this one has a value in front. Our a value in this case is a 2, which means that the slope on the right side will be a 2. My vertex, I have shifted it right 1, and down 4. So picture my vertex moving from the origin, right 1 and down 4. It's going to land there. So my vertex would be positive 1, negative 4. My axis of symmetry is going to go right through that. So it would have the equation x equals 1. My domain, we said, was always all reals. And my range, let's graph it here. We are going to do a slope of 2. So from my vertex, I'm going to go up to right 1. Up to right 1 to get the right side. And up to back 1 to get the left side. So all of my y values are greater than or equal to that negative 4. All right, looking at our next example, notice that in the front we have a negative 3. If our a value is negative 3, when we think about reflections, transformations, this is a reflection over the x-axis and a vertical stretch of 3. So picture our absolute value graph. If we reflect it over the x-axis, it's now going to be upside down, and it's going to get much narrower because we're doing a stretch of 3. So we're pulling that and making it get skinnier. For the vertex, we have to look at our left and right up and down shifts. So a plus 2 means we moved left 2, up 5 because of the positive 5. So our vertex is going left 2 from the origin and up 5. So my vertex would have the coordinates negative 2, positive 5. Remember, your axis of symmetry always goes through that vertex. So we're going to have an equation x equals negative 2. It's always going to match that. We said our domain is always going to be all reals. And our range should be less than something because we have an upside down v now. So let's look at this. If the slope on the right is our a value, which was negative 3. So on the right-hand side from my vertex, I'm going to go down 3 and right 1. Down 3, right 1. On the left side, I'm going to go down 3 and back 1. Down 3 and back to the left 1. So I have this upside down V, and notice the symmetry here. We are 2 spaces from our line of symmetry to get to this dot. We are 2 spaces on the opposite side to get to that dot. So my range in this case, because my highest value is up here at 5, I'm going to say that my y values have to be less than or equal to 5. All right. What about if the function looks a little different? Notice on this one that we don't have just an x inside our absolute value. We have a 2x. So let's picture factoring that out. I'm still in my absolute value bars. I'm going to picture factoring a 2 away from this, and it turns into that. And now I can take the absolute value of that first 2. The absolute value of 2 is 2. So I can pull that out front, and then it turns into the type of equation that we've been working with. So again, let's analyze this. Our first 2 here means we have done a vertical stretch of 2. That means the slope on the right is going to be a little steeper. It's going to be a 2 instead of a 1. We have moved left 2 and down 3. So our vertex, instead of being at the origin, is going to go left 2 and down 3 and land there. Coordinates of that would be negative 2, negative 3. Our axis of symmetry always goes right through there. So it would have the equation x equals negative 2. Our domain is always all reals. And let's go ahead and graph. So we want a slope on the right of 2. So from my vertex, I'm going to go up to right 1, up to right 1 to get the right side. I'm going to go up to and left 1, up to and left 1 to get the left side. And my range then, my y values is everything from -3 on up. All right. Now this one, our last question here is the reverse. I'm giving you a graph and I want you to tell me the equation. So the first thing you're going to do is decide, where did the vertex move? It used to be at the origin for just y equals the absolute value of x. All right, it used to be at the origin. We have moved it to the coordinates here, -1, +4. That means we have shifted it left 1 and up 4. Okay? On the slope, we're always identifying the slope on the right side. So let's find another point here that we can use. And if we can look at our rise and run, we're moving down 1 and right 3. So our slope is -1/3. That's going to be our a value. So my equation, y equals my a value, absolute value, x minus my h. In this case, h is -1, and plus my k value, which is a 4. Now we could clean this up a little bit and change this to just be an x plus 1. It still indicates a left 1 shift. All right, so analyzing our equation, y equals a times the absolute value of x minus h plus k. This a value identifies any kind of reflection over the x-axis if it's negative. So negative means we reflect over the x-axis, which means it would be upside down. Positive means it's going to be right side up. And our a value equals the slope of the right branch. And then the left branch is always the opposite slope. Okay? Our h value is going to shift left or right, and this is going to give you the axis of symmetry. And it's always also going to give you your x coordinate of your vertex. Your k value is going to shift things up and down, and it will give you the y coordinate of your vertex. All right. Let me know if you have any questions.